Okay, so hi everybody. I am Giulia. I'm working as a scientist at TNO, which is the Dutch Research Center for Applied Scientific Research. And I'm also working at the Center of Excellence for Data Sharing and Cloud, which is also hosted at TNO. I'm very excited to be here and presenting the work done with also my colleagues Koen Leeuwen and Bart Driessen in bringing Gaia-X and Myrtus together in order to create a digital ecosystem which is more reliable, more trustworthy, and that can enable the cloud edge fog continuum. Now, before going into the technical details of what we have implemented, I would like to give you some information about Myrtus. So, what is Myrtus? Myrtus is an European project on the topic of cloud cognitive computing continuum, which ran from 2024 to 2026. And the objective of the project is the one of creating a solution to orchestrate the cloud fog edge continuum in a way which is sustainable and secure. Obviously, for meeting and reaching this goal, trust plays a key role because we have to create a system where end user can trust that services behave in a secure way, that data are handled correctly, and that all the operations that are performed within this ecosystem, they are in line with the European digital legislative framework. So for this reason, we decided to use the Gaia-X trust framework and comes here very handy and help us in meeting our objectives. Now, but where do we use the trust framework? Myrtus built on 3 pillars. We have the reference infrastructure. Here we create an environment for connecting cloud, edge, and fog. Then we have a cognitive engine, which is AI-driven and orchestrates all the operation within the ecosystem and environment. And then also we have a set of tools that can be used by the developers for fostering interoperability. Now, we use the Gaia-X trust framework for new entities that they wish to join this ecosystem. So it's actually consumed by our Myrtus cognitive engine. Now, when we were designing this ecosystem, which was initially targeting the entities and partners that were in our consortium, at one point we asked ourselves a question. So what happens when a new entity wants to join the ecosystem? And can this onboarding process be automated? Can we continuously verify the conditions required for trust, security, and interoperability? And can the system ensure compliance dynamically as entities evolve over time, right? So as they join the ecosystem or they move. Okay, so with the Gaia-X trust framework, we can automate entity onboarding and continuous verification within this cloud fog edge continuum. Technically, what we do, we use a verifiable presentation that embed verifiable credential, and we automated the verification that the information of the entities respect and comply with a set of rules and requirements that they established from the Myrtus ecosystem. Now, this process follows a few steps. First, the system uses a Kubernetes configuration file of the entity which aims to join the Myrtus cluster to establish a connection. We retrieve, therefore, a secret which shall contain the Gaia-X verifiable presentation. Successively, we verify the authenticity of the verifiable presentation and verifiable credential by also checking the decentralized ID. We check the temporal validity, so if the verifiable presentation and credential are not expired, then we validate against the constraints that are created by Myrtus for the entities, basically that they want to join this ecosystem, so there are actual specific rules that are customized to the consortium and environment. We return a transparent verification report with the decoded header, payload, and validation results, and then if all these verification steps succeed, the system initiates peering of the Kubernetes cluster via LICO, enabling the entity, therefore, to join the Myrtus ecosystem. Now, regarding the validation, what do we validate exactly? The constraints that we have defined for our initial proof of concept, because we are continuously developing as Gaia-X also further develop, focus on verifying that the entities is in the economic European area jurisdiction, right? So it follows within this jurisdiction. So we created a set of shackle shapes that embed these constraints, and we checked that the legal entities registered in a European member state, so based on headquarters and legal address, and address of the country codes, whether the entity hold a valid lay code, and then if the entity has accepted the Gaia-X terms and conditions. Now, by creating these shapes with shackle that represent these actual constraints, that it's possible to validate with a reasoning engine for shackle to see whether there was actually these, let's say, requirements are met. Now, our framework, therefore, leverage Gaia-X verifiable presentation as the basis for creating a sort of automated compliance check. This approach allows us to validate the stricter European jurisdiction and data sovereignty requirement, that which criteria will be also part of the label 2 and 3 from the Gaia-X trans framework. So we validate one of these specific criteria. Now, I will show you a demonstration of our work in action. There should be also audio.
Hello, and welcome to the Myrtus Gaia-X Trust Framework demonstration. In this demo, we'll show how the Gaia-X Trust Framework is used to verify whether a Kubernetes cluster is eligible to join the Myrtus platform. To make this clear, I will first walk you through the main steps involved in ensuring a secure peering process. Step 1. We start by uploading a local Kubernetes configuration file. This file is used to retrieve the Gaia-X verifiable credentials that are stored in a predefined namespace and secret inside the Kubernetes clusters. Once retrieved, these credentials are represented as a JSON Web Token, or JWT. Next, we verify the token's digital signature and validity timestamps to ensure it's authentic and still valid. If that succeeds, we then validate the embedded credentials. These describe key properties of the cluster's owner. The validation is done using shackle shapes, which define the formal rules for what a compliant credential should look like. If all checks pass, it means this cluster meets the Myrtus requirements to establish a trusted peering, and the peering process can begin. Now, let's see this process in action. First, we upload the Kubernetes configuration file. Here, we can see its content, and when we submit it, it's used to obtain the web token. Once that is done, we can move to the next step. The web token is digitally encoded, so we start by decoding it to verify its signature. As soon as that's finished, we can see that the header confirms that it was issued by a trusted authority. Inside the token, we find 3 verifiable credentials, or claims, describing the cluster owner's properties. For example, one claim states that the owner is located in Hamburg, Germany. Another one confirms its agreements to specific terms and conditions. And finally, there's a registration number identifying the organization. Since the signature is valid and the timestamps check out, we can proceed to validation. In this step, we verify whether these claims conform to the Myrtus trust standards using the shackle shapes. Here we can see that all 3 claims successfully pass validation, meaning that the cluster is trusted and eligible to peer with the Myrtus platform. At this point, the peering process can safely continue. And that concludes our demonstration of the Myrtus Gaia-X trust framework. Thank you for your attention and for joining us in building a more secure, interoperable cloud ecosystem with Gaia-X.
Okay, so now if we go into the details of what we have done, here you can see one of the verifiable credentials that it's open. And you can see explicitly the information regarding the country code of the entity wishing to join Myrtus cluster. Using all the expressivity which is instantiated by Gaia-X ontological framework. We use specifically this in order to create the shackle shape in which we put a restriction regarding the countries that can join the cluster for supporting the digital sovereignty and checking whether the entities are part of the European Economic Area. And now let's see what happened when we remove, for instance, Germany, because this verifiable credential and presentation were coming from an entity, a German one. Okay. So here you can see that we remove directly Germany. We are going to rerun everything. Here you can see it's already, we already uploaded the configuration file. We move, and here we check whether the verifiable presentation and verifiable credential are actually valid. And here still pass, because obviously they are valid. Here again is for an entity of Germany. Now, if we go to the next step, where we have and the compliance check is performed using the shackle shapes, we can see indeed, because we removed Germany from the countries that are allowed, that this step doesn't pass, and therefore is not provided the possibility to peer automatically using LICO. Okay, so key takeaways. Myrtus embeds trust at the core of its architecture. So we are designing a solution which we support and foster the creation of trust by using Gaia-X trust framework. We use the Gaia-X trust framework to ensure secure, transparent, and sovereignty interaction, and verifiable presentation and the shackle shapes, shackle rules that we created, and the reasoning engine reasoning over shackle. Let us verify that entities, which entities can actually join the Myrtus ecosystem based on the constraints, and then enforce the European Economic Area jurisdiction constraints enforcement. Okay, so if you would like to know more about Myrtus, here you have a QR code, and if you would like to know more about all our research activity that we are performing at the Center of Excellence for Data Sharing and Cloud, here you can scan this QR code. Thank you very much.